In a simple national income model, national income Y is equal to consumption expenditure C plus autonomous investment I naught plus autonomous government expenditure G naught. Consumption expenditure C is equal to autonomous consumption alpha plus beta times of Y minus T, that is national income minus taxes, where beta lies between 1 and 0, and tax T is the delta times of national income Y. Here delta is also lies between 0 and 1. Now Y equal to C plus I naught plus Z naught can be written as Y minus C equal to I naught plus Z naught. C equal to alpha plus beta times of Y minus T. This equation can be written as minus beta Y plus C plus beta T equal to alpha, and T equal to delta Y. This equation can be written as minus delta Y plus T equal to 0. In the first equation, the coefficient of Y is 1 and coefficient of minus C is minus 1 and coefficient of T is 0 because there is no T. And in second equation, coefficient of Y is minus beta and coefficient of C is 1 and coefficient of T is beta. And in third equation, the coefficient of Y is minus delta, coefficient of C is 0 and the coefficient of T is 1. So this is the coefficient matrix multiplied by the variable vector, that is the matrix of or column matrix of Y, C and T equal to column vector of constant term, that is column matrix of I naught plus Z naught, alpha and 0. Therefore, the matrix notation of these three equations is matrix of 1 minus 1 0 minus beta 1 beta minus delta 0 1 multiplied by column vector of Y, C, T is equal to column vector of I naught plus Z naught, alpha and 0, or variable vector, that is Y, C, T is equal to inverse of the coefficient matrix, that is inverse of the matrix of 1 minus 1 0 minus beta 1 beta minus delta 0 1 multiplied by column vector of I naught plus Z naught, alpha and 0. Here, in order to get the value of Y, C and T, we have to invert this coefficient matrix. Let A is the coefficient matrix. Now, if A is a non-singular matrix or the determinant value of A is not equal to 0, then inverse of A is equal to adjoint of A divided by determinant value of A, where adjoint A is the transpose of cofactor matrix of the matrix A. The determinant value of A or the determinant value of the coefficient matrix is equal to 1 into 1 minus 0 minus minus 1 into minus beta minus minus delta into beta plus 0 because it is 0. that is equal to 1 plus minus beta plus del beta, and that is equal to 1 minus delta into beta. Here the value of this portion is not equal to 0, or the determinant value is not equal to 0. That means this coefficient matrix is a non-singular matrix, and we will get inverse of this coefficient matrix. Now the cofactor of element 1 is minus 1 to the power 1 plus 1, because this 1 is in first row and in first column, so it is 1 plus 1 into 1 into 1 is 1 minus 0 into beta is 0, so we get that is equal to 1. Similarly, cofactor of minus 1 is equal to minus 1 to the power 1 plus 2, because minus 1 is in first row and in second column, so that is why 1 plus 2 into minus beta into 1 is minus beta minus delta beta, so minus plus delta beta, and that is equal to minus 1 into minus 1 minus delta into beta, and that is equal to 1 minus delta into beta. This is where the cofactor of the element 0 is delta. The cofactor of the element minus beta is 1. The cofactor of the element 1 is 1. The cofactor of the element beta is delta. The cofactor of the element minus delta is minus beta. The cofactor of the element 0 is minus beta, and finally the cofactor of the element 1 is 1 minus beta. The cofactor matrix is, it is matrix of the elements 1 minus delta into beta, delta 1 delta minus beta, and 1 minus beta. So this is the cofactor matrix. Therefore adjoint is the transpose of the cofactor matrix, or the adjoint is 1 minus beta, 1 minus delta into beta, 1 minus beta, delta, and 1 minus beta. That is obtained by transferring the rows into columns and columns into rows of the cofactor matrix. Since adjoint of the cofactor matrix is this, and the determinant value of the cofactor matrix is 1 minus delta into beta, therefore inverse of the cofactor matrix is equal to the adjoint divided by the determinant value of cofactor matrix, and that is equal to 1 divided by 1 minus delta into beta multiplied by the adjoint of the matrix. Now in this matrix notation we put the inverse value of this matrix is this, and after multiplying this and this we get I naught plus G naught plus alpha equal to 0, that is multiplying by this row by this column we get this, and by second row and this column we get this one, that is 1 minus delta into beta into I naught plus G naught plus alpha equal to 0, and multiplying by this third row by the third row of this matrix with this column we get delta into I naught plus G naught plus delta alpha equal to 0. After simplification, we get this matrix, and finally we get the equilibrium value of y, that is income, or y bar is equal to I naught plus z naught plus alpha divided by 1 minus delta into beta. C bar, or equilibrium consumption, is equal to alpha plus beta multiplied by 1 minus del multiplied by I naught plus z naught divided by 1 minus delta into beta, and equilibrium takes as, that is T bar, is equal to delta times of I naught plus z naught plus alpha divided by 1 minus delta into beta. We can solve a simple national income model by using matrix inversion method. Thank you.